Hello and welcome back to compiler programming. In this video, what I thought to do is make our function argument handling a bit more sophisticated. So right now, I basically manually know that we receive an argument inside an RCX register, and this is not a sustainable long-term solution. So what would be nice instead is if we made it such that I can just say, okay, I want to get the first argument or the second argument, and we'll get the right register automatically, or maybe not even the register later on, because if you pass argument that is larger than 16 bytes, then you will not get register. And if it's between 8 and 16 bytes, you actually will receive it inside a SSC register or XMM register. And not inside the standard register. So this is something that we'll also have to support at some point. Also, the float arguments are in different registers, and right now we don't even have a concept of a float. But anyway, for now, let's just focus on this standard integer arguments that we can pass in standard registers. And I would like to first move our functions a bit up in the code because we'll need to use them earlier than this. Or we can just move these two. Yeah, let's just move these two things down a bit and start converting them to our function code. So, okay, we do function begin, and then return is function buffer memory. Instead of just buffer memory, we remove this stuff, and we also do return. Return, and here we can actually directly say, I believe, return immediate 32 of value. And let's see if that actually works. Okay, let's run test. Okay, cool. We didn't break our constant function. That's great. And it is now looking much better and much closer to what you might think of as the as a kind of DSL that we would eventually have for specifying something like this. Okay, now we also do the same transformation to this one. We remove this thing, and then we say right away that we return our RCX register, and this is where we would need to make some changes to actually say, I just want to return to you the first argument instead of I'm going to return to you the RCX stuff. Okay, it should be function. It's fine. Let's try test it. Okay, cool. So we did our refactoring and everything is to work. Let's recheck that everything is actually been recompiled, and indeed it is. So that's good. Let's stage this stuff and prepare for the next step. I'm not sure what would be the best way to access the arguments, but I guess what I can do for now is have something like parent arg0 that is function argument of function, and we also need to specify the size. And the way I'm going to specify the size is with size of, because that way we can actually later on maybe turn this into a macro and just say, okay, the first argument is S64 and we'll insert it here, we'll insert it here, and or something like this. I don't know. Okay, operand 0 is function argument, and I think I also will have like an implicit counter inside the function that just checks how many arguments we asked for, because in general the function itself doesn't really care how many arguments were passed to it. Like, you know that there are these var_arg functions, and because it is the caller that pushes arguments on the stack, I believe at least that it doesn't really matter how many arguments were pushed. If we don't want to use them, we're not going to use them, and that's fine. Okay. So what would that function arg look like? Let's see. We have function arg. It returns to us an operand, and it accepts two things. It accepts function, and it also accepts size, which is, I don't remember what we used in operand for the size. I guess we used U32. Okay, so U32 by size. That's good. And now we need to change the definition of the function. Where is our function definition? It's here. Missed it. Okay. So how do you want to deal with it? I guess we will need to have some way to store how many arguments are there, but in general, actually not really for now. We probably not even care, but we do want this implicit argument index, which is, or more explicitly, next argument index, so that it starts with 0 and this is the correct index. Okay. And now we have our function arg, and we say switch of function next argument index, and afterwards we will just get the next one, prepare for the next call. And here we say case 0, return RCX, and right now we will not support arguments that more than 4 arguments. Not more than 4 arguments are not supported at the moment. Okay. Just in case, this trick basically, like assert expects a truthy expression, and since a pointer to const char is a truthy thing, we just negate it, so it's always going to be falsy, and this assert will fire, but because it's a macro and it actually takes this expression for the message, this provides us a much nicer error message. So it will actually see what is the error is, unlike the situation where you sometimes see people just doing error false, which does not give really any information and is kind of nasty. Okay, so case 0, case 1, case 2, case 3. I do not remember what are the registers, so let's try to check this out. We want this x64 calling convention, and there is this nice table here. Okay, it's RCX, RDX, R8, and R9. R8 and R9 are actually a problem for us a bit because we are not ready really to support them. Maybe this is something we also will do in this video. Let's see. And the reason I'm saying that we are not ready to support them is because they need rex bit to encode them. I can show a bit later what it means. Okay, but for now we just say RDX, then oops, R8 and R9. Cool. So this is gonna give us back the stuff. And for now, let's do another assertion that byte size is 8, because we are not ready to support any other byte size, because we'll need to change these how these registers actually behave. But for now, that's not important. Cannot convert, yes, of course it can't. Well, actually, we should do this like this, because we will never actually get to here, and here we say, like, we're never actually gonna get to here, so maybe I can do this. Do I even need to specify this, or does it know that the assert never? I guess not. Oh, maybe it is, yeah. Let's do it like this. This is fine. arg0 is not referenced. It's good. We pass it here. We build. Something is still not correct. Not all control path. And this is a problem with the assert definition here. I actually have no idea how it's defined, but apparently the compiler does not know that this thing that never actually will return. Oh well, we will return an empty operand. That's not a big problem. Good. Let's check in on our tests. Ideally, everything should still be fine. And it is, which is very, very neat. Let's convert the rest of our code to use arguments and see that everything else still works. Okay. So function begin, we declare 2 variables. That's fine. Now we need this arg0 like this. Builds. It still works. Great. Let's take the next one. Here we call our arg0. Apparently I copy paste too much. Like this. Okay, that's good. We also probably would want to make call actually return us an operand, because so we don't hardcode arrayx. But this is a bit more tricky because we need to know what is the return type of the thing that we are calling. And I'm not yet sure exactly how we'll do that, so we'll leave it for a bit for later. Okay, but let's continue with our argument cleanup. So here we use RCX, which is not great. And so it looks like this. Yeah, this we cannot yet fix up for the same reason as mentioned above. Like we need to figure out how we deal with functions in general. We'll probably need to have meta information, and instead of passing, we'll need to have a wrapper type around C function pointers, I guess. But let's see how we deal with that. For now, this is not what we're working on, so we can just ignore it. Great. So we can have, we have a bit of a crash, which is fine. For now, we are working on something else. And what I mentioned when we were doing the encoding here is that R8 and R9 are actually not going to be encoded correctly. So let's try to do that. So we will create a function that will return to us the third argument. And that should show the problem. We can copy paste make constant. Honestly, I don't even think we need to have a small function like this. We can just inline it into a test. It should return third argument. Okay. Begin, then we say blah blah. Function type will be let's, I guess, start with S64 and then we'll deal with other sizes afterwards. So function type S64 to S64. Actually, that's not correct. This S64, S64, S64 to S64. So we have 3 arguments and we want the third one. Or we can even do 4 arguments. Why not? What's gonna be third? Call it third. Is this? And then we say that S64 result is third of 1, 2, 3. And we expect that result is 3, right? So what is inside of this function? Obviously, we want to return stuff, but also we want to get our third argument. And because I use that implicit counter, we actually will need to get all other arguments, but I don't think that's a big problem. Did I call it fn arg? Already forgot what I was doing. Yeah, it's a fn arg of fn, and then we say size of 64. We are not actually interested in the return value, so let's be maybe explicit about it and say we don't care. We know that this thing returns stuff, but we are not going to use it. We're also not going to use the second argument, but we are going to use the third one. So operand arg2 is this. It's always tricky, like which kind of indexing do you want to choose? One index or zero index? And I haven't really made up my mind what I think is the right option here, to be honest. I never really used a language that used one-based indexing, but maybe that's honestly a better way. I don't know. Anyhow, arg2 and return arg2. What don't you like about this? Okay. Missing stuff here. This is fine. Yeah, it cannot find this type, so we'll need to add it to our type definition. Let's do that. 64, S64, S64. S64, S64. Okay. That's a lot of S64s in this line. Let's recheck they haven't messed up. Function type is seems to be okay. Too many S64s here though. What's wrong? Function data pointer. Okay, yeah. Yes, it's gonna be like this. Great. And let's see what actually happens when we try to run this. It does not work, which is exactly what I would expect to happen. Is that because we don't properly support encoding of these registers. So let's fix that. Or let's first check that we are indeed, it is indeed the error that I'm thinking it is. It's always, doesn't hurt to verify your assumptions. Years of debugging distributed services taught me that the hard way. Come on, Visual Studio, you can do it. Is it ready? Is it ready? Okay, looks like it is. So let's add breakpoint here, I guess. Continue. I also figured out how to bring up this register window, so now we can properly see all the registers and the flags. So everything is great. Except the formatting is just completely ridiculous. And I'm not even sure how could I make it nice. I guess like this. Like, why is this indented but this is not indented? This is very, very strange. Anyhow, let's switch to disassembly. Then we will jump over run to cursor. Okay. So what is happening here is we are loading the arguments, and this is, yeah, and now I also know how the registers are called, which is something I will need to add in a second. So I didn't remember how the 32-bit version of R8 is called. Apparently it's called R8D. Cool. Now let's go inside the call and see what we have here. Yeah. So this is exactly what I was expecting. The thing is, R8 and REX are both have the bottom 3 bits 0. Let me try to show you this. So I can stop this. So this is REX and this is R8. REX is index 0, R8 is index 8. And if you look here, like if you look at the binary version of this, 8 is this, and this is obviously this. So the only difference is in this top bit. And when AMD created this x86-64, they wanted it to be completely backwards compatible with existing x86 encoding. So like if you don't look at these bits and you don't use these registers, then everything is fine. But if you do need to encode this register, you need to put this bit somewhere. You can't put it in the same place as we were putting all other bits because it's full, right? So, and to be more precise, this is where we were putting it. We were putting either here or we were putting it here, I guess. Yeah, in one of these. And you can see here I'm using this mask to even like to remove that one, because we don't, when we are using opcode, we also don't want to add this there. So we need to figure out where to put that bit. And that bit goes into Rex register. In particular, like for now, we are ignoring the SIB because the only thing we use it right now for is stack pointer. Stack pointer is one of the lower registers, so it doesn't need that extension bit, and we're not even using index field. So like we just, for now, this is not what we're interested in. We are, however, interested in these two. So this is an extension of mod_rem version of register encoding. And I believe this one is an extension of like definitely opcode register build. I'm not exactly sure what they mean by mod_rem field. So I don't know if I need to use rexr or rexb, to be honest. But this is something that we can look up just by trying to encode this instruction that we are trying to do, right? Because this is very straightforward. We open our trusty online assembler and just do very straightforward thing, move REX R8. Go. Okay. And now we need to make sense of this. So I'm only interested in this particular byte, so we can bring up the calculator. We can say that I'm in hex and I do 4C. And let me try to make it larger. Actually, it doesn't increase the font size. But anyway, so 4C is this bit pattern. We already know that we are putting rexw into it, and this is responsible for this bit. That means that the other one that we need to put in this case is rexr. And to verify which version of the move it's using, it's using 89, so it's using this encoding. And we are changing the source, so the register version. Okay. mod_rem reg field, mod_rem erm. Okay, great. I actually misread what was written here. So yeah, now everything makes sense. When we are trying to extend this register, we will need to put rexr, and if we were trying to extend this register, we will put in rex b, and we can verify our assumption by going here and swapping these things around, or maybe even doing something like this, r9, r8. So in this case, we have value 4G. Let me clear all this. So let's switch back to hex. Let's do 4D. And indeed, in 4D, we have both rex R and rex B set. And if we say R9 RAX, then it will be 49, which means that only rex B is set and rex W is set. Good. This is what I wanted to know out of this experimentation. Let's try to implement this. So for the opcode, we need to say that if operand register index is like this, then we do rex byte or equals rex r, check, rex r, yeah, modern, actually no, it needs to be rex b for opcode red field. Let me copy paste this so I have it closer to where I want, or maybe let me open a second editor just as a reminder. Okay, so in this case it's going to be rex b, and what are our other options? Yeah, we also need to do this one. So if our operand type is register and encoding type is register, then this is also rex r, I guess. And then if in this case, if it's rm and we have register, then we need to do rex b again, because it's mod rm field, and this is what we're encoding here. As I said, I will for now just ignore the zip version and do something else. Good. Does build. It does build. And let's see if we have improved our code. Go to disassembly, run to cursor, jump inside, and it still does not do what we want. It still says 4889. Yeah, because I need to rebuild it. Okay, that's interesting. I guess we want to check what this function does. So return, let's go inside. It's fine, 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 fine. It's fine, it's good. Let's step inside of encode and see what's going on. We try to make this slightly bigger. Let's run to here. Because we're not interested in the exact match, we're more interested in the encoding. Right? So this is fine. Let's see what is inside of the operand. So operand type is register, and then encoding. No, not encoding. Encoding. No. Press the wrong button. Now we have to do it all over. Oh well. Okay. Good. Coding type is immediate. No, it's not initialized yet. Okay. So register memory. Operand size is 8 bytes, so we need rexw. That's good. Now we check this. Okay. Yep. RM is actually not. Yeah, RM is 0 because we are moving to array X, so this is actually correct. This will skip over the regs. Okay, that's fine. That's fine. It's this operand that does not seem to be encoded correctly. So the register is 8, which is fine. It is 8 bytes, but we already put the rexw marker, so it doesn't really matter, but doesn't hurt us either. The encoding should be operand type register, yes. The encoding type is also register, yes. Now we need to do this. Rag or opcode is this. It's good. And so we are setting rex r. Is it not correct? Oh, yeah, that would do it. So this is just a copy paste problem. We were ifing on one thing, but then putting another thing, which obviously doesn't really work. So now let's do it again. And we go here, we go to cursor, we jump inside, and we have a winner. So move array X R8, which is exactly what we wanted to do. So blah, 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 everything is fine. Continue, and if we run the tests, I bet everything is going to be great. Cool. So let's recap what we did in this video. The first thing is we now have a way to refer to arguments without knowing the register, and obviously we will expand on this in the future. And the second thing is we got rid of another fixed me. In particular, we can now correctly encode registers that need this extended bit. Great. With that, thank you very much for watching, and see you next time.